Okay, now we're going to develop forecasts using the second model, and the second model has three variables, dxf1, dxf2 and dxf6. So let's assemble those values for the holdout sample here. So dxf1, dxf2, dxf6, and then we're going to find, based on these values, forecast for dy sub t. So we start from here, dxf1. Okay, we didn't need this either in the previous model. So we need the d values for xf1, xf2, xf6 starting from the very first row of the holdout sample. So dxf1 is in column AZ, okay, and that one. Okay. Now dxf2 is right next to it, so we can copy that like that. And for dxf6, that's going to be dxf6 is in column BE. So BE 180 will give you dxf6. Now we can copy this for the holdout sample. Okay, so now we have the x variables. Now the coefficients for these will come from the results. So here this is our y-intercept. Okay, now we have the variables going backwards from right to left. So the first one is dxf1, the second one from going from right to left is dxf2, and then finally dxf6 over here. So the coefficients are slope coefficients. So dxf1 comes from there. Okay, dxf2 is that one, and dxf6 is that one. So those are the coefficients. Okay. Now let's assemble the coefficients here. For dxf1 is that, dxf2 and dxf6. Alright, now let's set up the forecast for dy sub t. So that will be the y-intercept first, absolute reference that, plus we can now do a sum product. Okay, now that we have the coefficients assembled properly, so we'll do a sum product of the coefficients. Okay, we have to absolute reference that with the difference values for xf1, xf2 and xf6. So that will give us the forecast for the difference in y. Now what we want is forecast for y sub t, in which, as we have already discussed previously, we have to add the forecast of the difference to the actual value of y in the previous month. So forecast is going to be the actual value. So we take the actual value from the previous month and we add the forecast of dy sub t, and that will be our forecast for y. So again, now that's the forecast for the holdout sample based on the second model with three independent variables which are difference variables. Okay. So now let's evaluate these two models with respect to the forecast accuracy measures. So we start with mean error. Okay, the actual values of y, comma the forecasted values of y. So that will give us the error, and we'll do MAE and MAPE next. So we have MAE okay, and the ranges, and MAPE and the ranges. So now you see the percentage error for the holdout sample is really small, 5.6%. Okay. Now let's do the same thing for model 2. So we have M error, the actual values of Y, comma, forecast of Y using this second model, which is that. And M error, remember, it measures the bias. Okay, next is MAE, and we give the range. So the second model has a slightly higher MAE for the holdout sample. And the MAPE is also slightly higher. So between model 1 and model 2, it's now very clear that the simpler model actually gives us slightly better results in the holdout sample. So our choice is going to be a model with difference in Y as your dependent variable, the response variable, and the difference in just one X variable, X sub 2, as your independent variable, and that gives us very good results. Now let's compare this with the previous one, which was auto-regress, the errors being auto-correlated. So there the MAPE was 4.97 and MAE is 11.92. Okay, so which is slightly better than this model. Okay, but mean error is kind of a little high, so it has a little more bias towards the higher side. Of course, when we don't take any differences at all, the original values, then our accuracy measures are really poor. So far, the two models which seem to give us reasonable results are, one is taking the differences and the other is recognizing the autocorrelated nature of the residual errors.